Problem 29 in section 1.1. Now, suppose we have a continuous function f that's defined over the interval ab, and there are 2 points x1, x1 in the interval. The first part is to show that there exists a number c that is between x1 and x2, so that f of c is equal to this value, the average of x1 and x2, f of x1 and x2. Second part is to show this is still true when you use this combination. The C1 C2 are both positive, and it's kind of combination of x1 and f of x2 in this way. And finally, to show that this may not hold when C1 and C2 have different sign, and their absolute value are different as well. Because if they're equal, then this will be not defined, but the denominator will be 0. Okay, so actually this is a very simple question because you look at the first part, you have a function f defined over focus on the interval between x1 and x2. So you know the function half of f of x1 and f of x2 will be a number between f of x1 and f of x2. So by the intermediate value theorem, there must be a point between, so there must be a point between x1 and x2, so that is taking the value like this, right? Because this is nothing but a value between, we'll say, this is the value between the minimum value of f of x1, f of x2. Right, just choose a smaller one, maximum of f of x1, f of x2. The reason is that f of x1 and f of x2, there must be one smaller, one larger, right? So, well, if they're equal, then you just choose your x to be x1 or x2 because they're always the same. If they're different, then one is larger than the other. Let's say that the smaller one is here, the larger one is here, and then the average of those two must be in between those. So by the mean value theorem, we know that there must be a point that is taking a value in between, since the function f is continuous. Okay, the same idea applies to the second part. So this is nothing, just a new combination of the two values here, and it's also between this. So you can actually copy this right down to here. It's also in between this, because this is usually called a convex combination, because this is essentially just a C1 over C1 plus C2 times f of x1 plus C2 over C1 plus C2 times f of x2. So you can see that these two numbers add up to 1. And this is and both of them are non-negative. So it's actually, if you think in this way, let's say this is let's say f of x1 is smaller than f of x2, then this number is just somewhere in between, right? The extreme case is that if c1 is 0, then this will be just 0, and then this will be just c2, just the 1, because c1 is 0. Okay, then in this case you're just reaching to this point. If c2 is 0, just reaching there. If c1 and c2 are both positive, it will be somewhere in between. So anyway, some number between these two. So for any number, for this number in between, you know that by intermediate value theorem, there must be a point that taking this value. If actually any net value in here, you will be able to find a point that's taking value there. Okay, so that is just by intermediate value theorem. Per se, this could be wrong if your C1, C2 are one of them is negative. So this is a kind of, this is what I call a convex combination, so that it's always between here. But if one of them is negative, then you can go to this side or to this side. In that case, you know that the intermediate value theorem may not work. For a simple example here, let's look at the function f of x. It's just equal to x, very simple function, defined over this interval, -1 to 2. Because f(x) is just identity, so the value of f is also between -1 and 2. Now, if I take c1 to be -2, c2 to be +1, and x1, x2 are just these two endpoints here, then we can try this value. This value is going to be the C1, C2, as we said, is -2 and 1. And x1, x2, or fx, x1, x2 will be just -1, 2. And again, copy down C1, C2 here. You can see that the value is -4. And that is apparently outside of this interval. Okay, that's why you will not be able to find any point that is taking -4 over this interval, because the values can only be -1 to 2. So this is the counterexample, and it means that if C1, C2 have different sign, then this you cannot find a point taking this value.